and welcome to Super Strength ESLint with me, Josh Goldberg. Everything in these slides is on my website at joshuakgoldberg.com. If you'd like to go there to follow along, that works great. This presentation does include a lot of animated looped images. If those are distracting for you, I definitely would recommend viewing in parallel with the PowerPoint viewer online so you can pause those GIFs. Today's agenda will be, first, we're going to talk over the basic premises of ESLint, which is a tool that can find and fix issues in your code for you. We'll take a detour for a little bit after that to explain how it is or isn't the same as Prettier. Then we'll get back on track by showcasing some really awesome built-in ESLint rules and how they can improve your code base. Later, we'll get a little more hands-on with the underpinnings of how ESLint rules actually work with custom ESLint logic that uses ASTs, or abstract syntax trees, which is the core of ESLint. Last up, we'll use our shallow ESLint understanding and then augment it with TypeScript. First, with a few rules that come with the TypeScript ESLint integration, which necessitates understanding what TypeScript actually does for us. And then we'll write our own custom rule that uses some of the TypeScript APIs. It's going to be a good time. Let's get started. So what is ESLint? Why are we here? Why do you care? At its core, ESLint provides a list of rules that each flag your code for some different potential code flaw, along with ways to run those rules. Each rule may report complaints as it comes across them, and optionally may suggest a way to automatically fix those complaints when it's possible to. From the start, we should note that ESLint is super duper configurable. Configuration files at the root of a project or specific to subdirectories can customize it. You can add community recommended rule sets, write your own rules, use different parsers for different languages such as TypeScript. We won't see it today, but just know that in your code, you can have little inline comments that enable, disable, or reconfigure ESLint rules on a per line, per block, per file area. ESLint really is a great customizable tool, and I'm pretty excited to talk about it. The way I see it, ESLint and other forms of static analysis are a key part of what I call the ideal bug acquisition funnel. Think of all the possible strategies you could take to reduce bugs in your end product, and maybe view them on some sort of long process that starts with all the possible bugs that could have existed in your application in the first place. You're top of funnel, you're 100%. Then it stretches down through the different methods that you have for getting rid of those bugs, and then ends in your user's hands. Hopefully, some amount of prior thought, maybe some good developers on your side can help you reduce a pretty significant chunk of those bugs. A good application architecture, good solid team development dynamics, that's good stuff. But it can't get all the bugs. Static analysis comes into play at development time by helping you catch little inconsistencies and potential bugs in real time as you type or build your software. Note that that's different from something a little further down the funnel, which is dynamic analysis, such as unit or end-to-end tests. And those run at least partially working versions of your code, so they tend to be a little slower in the development cycle than pure static analysis. For team projects, you can generally have peer review to get more eyes on your code and catch bugs or other faults just from looking at it, or maybe having other folks on your team try it out during the review process. After that, I hope you somehow have some kind of feedback or telemetry from your users, maybe some automated crash reporting as a form of telemetry, maybe some user feedback channels as a form of direct user feedback. It's incredibly rare for a software application to completely catch and fix its bugs. So even at the end of the funnel, it's important to have this stuff. This funnel, therefore, does assume that if you look really closely at the end, there is still that little sliver of non-zero percentage for bugs. But that doesn't mean that the funnel's useless. It doesn't mean that any individual piece of the funnel isn't worthwhile. We don't just stop doing testing because it doesn't catch all the bugs. Each of these things alone is something of a good motivator to get rid of bugs. So I think they're all pretty worthwhile to at least consider having on your project. A few necessary caveats. This funnel diagram is certainly not to scale with any precision, nor should it be applied uniformly to all software projects. Every project is different. If you skip some parts of the funnel, that might not be a problem. Your little weekend project might not have the same needs and requirements as, say, a Mars rover. You might be adding to the bug load later on. Who knows? It's up to you as the person who, in this fantasy universe, arranges and coordinates your process dynamics to understand what you need and what you don't need. Anyway, back to eslint. You can get started with it in a JavaScript project by running just these two commands. The first, npm i eslint -- save dev, adds it as a new dev dependency in your package, so you can save it for later. Then npx eslint -- init runs the eslint installation wizard, which creates a basic configuration file in the root of your project. That init command is pretty sweet. It'll ask you a few questions about your project type, browser versus Node, React versus Vue versus neither, etc. And it'll create a customized configuration for you based off of those. It's pretty useful. Once eslint is configured in a repository, it can be run on the command line by passing in any number of files or file globs to check, file path that is. I strongly recommend also using an editor extension. You can see the VS Code one in action here. It's pretty great. In this code snippet, it's showing off that you get little red squigglies when the code is producing rule complaints. Specifically, the complaints we can see here, both in the command line and in the extension, are two. One is on the first line, that no unused vars, which is a rule that flags unused variables, sees that the incorrect variable name is never referenced. It must be an unused variable. WAT with two A's. The second is no undef, which is a rule that flags references to unknown undeclared variables, sees that when the name is mistyped on line 1, line 3 therefore references a variable that does not exist. If you're going to take away one thing from this talk, this slide is the thing that I would really like it if you took away, that you can run eslint on your code. If there are no complaints, it's fine. If there are complaints, it'll report them to you. You can do it on the command line. You can do it in an editor extension. It's a bunch of rules, and each of those rules might create some complaints for you. Super. If there's one other thing I very, very much desperately wish for you to take away from this talk, it would also be the concept of prettier in regards to eslint. It is not the same as eslint. It has some pros and cons, and there are times when you'd use one or the other. Most importantly, please don't use eslint as a code formatter. Eslint is a linter. It's a tool that picks up on occasional problems with your code behavior, the real behavior of the code, the naming, the usage, the declarations. That's different from a formatter, which is a tool dedicated to formatting your code, the white space, the end lines. Linters are notoriously bad at enforcing formatting opinions. Please don't use eslint as a code formatter. From a little more technical perspective to justify that, lint rules around whitespace formatting are really hard to write. They're inherently buggy and really difficult to maintain. Architecturally, Prettier is very different. It's faster, it's more stable at applying formatting. We'll explain a little bit more of that later. And it doesn't need to have so much edge case logic the way eslint does. Also, its website has this great animated logo, which is pretty sweet. So please, don't use eslint as a code formatter. Use Prettier. Prettier is great. A little bit more supporting documentation, since I know some of you are grumbling right now. The core eslint maintenance team has stopped accepting new options for stylistic rules. This is as of last May. As they say in their blog, there is no way to satisfy everyone's personal preference, and most of the rules already have a lot of difficult to understand options. That includes rules for spacing. We've even put in some pretty explicit language and command line warnings in teslint to eslint config, the converter that transforms configuration files for the old teslint project, which was a TypeScript code to eslint. It's now deprecated. You should not use that either. And takes those configs and converts them into their eslint equivalents. I have to give a nice fellow named Brad Zacher credit for proposing this text. It is one of my favorite things. You can read more about all these tools and blog posts, by the way, again, in the slide annotations available on my website. That little highlight here is also a very good technical tip. If you do want to use eslint, which I would highly recommend, and you do want to use Prettier, which I also highly recommend, use eslint config Prettier. This is a pre-made Prettier configuration for your eslint config, meaning it tells eslint to disable any rules that would conflict with Prettier auto formatting. It gets rid of all of those annoying whitespace rules that no one wants to maintain on the eslint side. No more conflicts. I won't go into configuring Prettier to showcase how these would work together, but it's pretty similar to eslint. You can read more on its websites, prettier.io. I'd highly recommend it again. Anyway, moving on to the ESLint rules. I'm really excited about these. If there's a way to convince someone, I think these rules showing off the bugs they can find would be the way. First off, I don't know how to pronounce this. I say equals equals equals. I've heard people say ek. Fine. It's a rule name for the rule that refers to the triple equals operator in JavaScript, most of the time being preferable to the double equals operator. For those who are attending and haven't really familiarized themselves with JavaScript yet, it's a great thing. Double equals in this language allows coercing a value a little more from the left side to the right side. So primitives that have the same stringified equivalent, like in this example, the string with one character 1 and the number 1 would end up both being stringified and then getting compared to each other, which is true. So string 1 double equals 1 in JavaScript. Triple equals does not suffer from this bizarre circumstance, which makes it preferable for most comparisons. For those of you who are attending and are grizzled agents of the language and are already rolling your eyes and feeling bristled that I have retaught you this language basic, first off, calm your ego. It's all right. Everyone mistypes occasionally, and it's just useful to have a little rule that can catch this stuff for you on the side, let you know, hey, I know you know this, but you only put 2 equal signs there. Secondly, since most or all of you are on some team that has people of varying JavaScript experience, it's really nice to have automated tools to tell people the quirks of the language. There are a lot of JavaScript quirks, and lint rule complaints can be a very effective form of knowledge sharing when the messages, of course, are set up well and have informative documentation. We can nudge newer JavaScript developers towards understanding these bizarre language quirks by putting barriers such as ESLint rules, blocking them from using the weird parts of it improperly. Good stuff. We're really dodging a bullet on this one. Array-callback-return is something that even those grizzled ancients, I'm sure, could use. I certainly love this rule and use it. Everyone here has either never used the array reduce, or they have spent way too long debugging it for throwing an error. I'm sure that is a true statement. If you've forgotten reduce, as everyone does, you need to return the memoized accumulator at the end of it, which is very easy to forget. This rule will make sure that you're doing that. It'll tell you, hey, you forgot to return it, so it's going to crash. Very useful to have ESLint do this for you instead of after 20 minutes of debugging in Code Sandbox crashing. Good stuff. We also saw this earlier. We just want to be pure with our unused variables. It's a rule that reports and removes variables whose values are never read. It's very easy to leave things in the code by accident that you don't use. So this rule is pretty useful for just the obvious caching unused variables. It's also really useful in a few more sneaky ways. If you set up a variable and then don't use it, it might be because your code logic isn't doing the things you thought it should. That might be a sign of a bug itself. Looking at this example, let first equals Josh is a variable declaration that's unused, but it looks like in the console log, the developer probably meant to console log the first variable and then rampant. So this unused variable is a symptom of a bug in the code. It's not just some cruft that should be deleted. Bug. Another fun thing is eslint-plugin-react-hooks. I mentioned ESLint can be augmented with custom rules. One very common and great example of this is a pattern of framework and library authors also publishing a compilation or a set of companion plugin rules to enforce best practices with their rules, with their frameworks. React is a fantastic example of this. They recently released a somewhat tricky new set of APIs called hooks, where you need to call things in the same order every time. You can't conditionally call them. There are rules about what you can pass as dependencies to them. It's a great set of APIs. If you haven't played with hooks, I'd highly recommend it. They're really cool. But without something like ESLint verifying proper behavior, it's really easy to mess it up and cause a bug. So as the React team docs strongly allude to, it's a very good idea to use the ESLint rules to make sure you're using hooks properly with React. There are similar things for other frameworks, Angular, React, Vue, they're all pretty linted. Fun. Well, speaking of larger frameworks, it's very common that you might want to automate some large changes across your code base. It might be something as small as removing unused variables, or it might be something as big as, say, sorting your imports. And ESLint rules, they're not the best code mods out there that belongs to tools such as JS CodeShift, but they can be used as a pretty good code mod provider. One really good example that I like is eslint-plugin simple import sort. What a name. It'll automatically sort your inputs for you. That's really nice. If it wasn't automatic, I don't think I could justify the time expenditure to get those darn things sorted. We won't look at it today, but there are a lot of projects that have released rules that help enforce that when you have a newer API version usage with breaking changes, it might automatically fix it for you to use the new one, which will be partially the crux of a rule that we write later on with TypeScript. So get excited for that. Anyway, moving on to the auto fix option. There is a -- fix command line flag in ESLint that you can use. There's also the editor integration. So if you were to type in the same command to run ESLint on the command line, -- fix after that, and hit enter, voila, it can fix stuff for you. And it'll even let you know, as you see in the error here, if you didn't fix things and they're fixable, you can. Thanks, ESLint. And just a quick peek at the editor extension for VS Code. 2 clicks, and voila, the things are moved. Good stuff. Let's talk a little bit about how these work on the inside. As I mentioned earlier, abstract syntax trees, or ASTs, are the core concept that we really need to surface dive into to understand how ESLint rules work. An AST, or abstract syntax tree, is a bare bones, quote-unquote, tree representation of a source file. By tree, we mean each section of the file is represented as an object, and each object has properties and maybe some subsections, which are other objects, representing its children or members. There are some standardized formats used for standard static analysis tooling. We're going to be looking at the ESTree format, which is what ESLint uses. If you were to map it out, it might look like an upside down tree or the roots for a tree. Let's do that. You might have a console.log hi, which is what's called a call expression. We're calling something. Expression refers to the general type, and call is specifically that we're doing something that is calling. This console.log hi has 2 children in our tree. It has a member expression retrieved in console.log, and it has the argument, literal hi, that's being passed to the call. So we're saying console.log, the member expression, is being called in this call expression with hi, the literal. Console.log itself has a couple of children. It's got 2 identifiers, a console and then the log. Okay. All your code can be represented in a tree form this way. This isn't just used for, say, static analysis. This is how a lot of, I believe most or all mainstream languages parse and run the code. JavaScript engines such as Babel or Webpack will coordinate some sort of tree parsing, which then outputs some other form of a tree as text. This is a really core concept if you ever want to dive into JavaScript tooling. So if this is of any interest to you, I definitely recommend follow up after this. Check out things like Babel and ESLint. It's fun. If this doesn't make a lot of sense, if you're not really this type of a visual person, let's look at another representation where we can discuss the entire tree in a flat JSON or plain old JavaScript object form, whichever you prefer. Going back through it in order, we have the console log, which is a type call expression, which has 2 children. It's got a callee and an arguments, where the arguments just has one thing. The callee is a type member expression. It's the console.log, and the arguments has that literal in it. Its value is hi. Now, the member expression has a console as its first identifier and a log as the second identifier. So that's the plain old JavaScript object form, which can also be represented as a JSON form of our code before. This is what we mean by it being an abstract syntax tree. Although the ASTs used by ESLint do store the exact white space positioning, this thing is abstract enough that it's not really a plain raw text document. It's just representing the structure of the tree, how it's generally supposed to behave. ESLint, as I mentioned earlier, is not the only tool that uses these. Prettier, use ASTs to auto-format your code. Instead of memorizing and coding down every possible little way that your code might need to be printed onto the screen, Prettier instead does a much simpler approach. It parses in your file as an AST, and then it prints that AST back out using its own formatting rules. This is why it's super stable and deterministic. It doesn't care what your formatting rules were ahead of time. There's a few very rare exceptions. It just creates the abstract representation and then prints that back out onto the page. It's beautiful. I love it. It's so simple and elegant in its implementation. They even have a restricted set of options for users because it's supposed to be just such a simple rule. Anyway, back to ESLint. ESLint rules use these file ASTs to reason about your code. Instead of trying to parse through your text manually, this is a structure that's a lot easier to understand. Rules will query for nodes that look a certain way with selectors, kind of like CSS selectors. They're similar syntax. And then for each of those nodes, there might be a complaint registered for that node. And for each complaint, there might be a fix registered. I just want to show a real cool tool. Before we dive into that AST stuff for ESLint, as I'm going through this, you might enjoy using astexplorer.net, which will help you follow along. It's got this really great interactive visualizer for going through an AST. You can toggle different types of data shown in it, use different parsers. The default for now is fine. You can see here that it's showing the tree structure in the POJO form on the right and the source code, which you can type in and edit on the left. Another cool tip, if you are ever confused about what a particular piece of syntax is called when you're trying to Google what it does, type it into AST Explorer and see what the AST says its name is. So then you can Google that. I find that to be really useful when I'm learning language. Anyway, this is a very rudimentary ESLint rule. It's almost as simple as I could possibly get it. If you're curious about understanding more options on this or a few fields that I left out for brevity, there are several great documentation pages linked in the docs here. The ESLint docs explain why and how the rule format is and is the way it is. And then the ESTree and ESQuery, which is the selector documentation, projects have great playgrounds and pages explaining them. Anyway, this thing starts off with some metadata to start the meta property. Under that, we store the list of messages that this thing could print out for errors. There's only one, the equal, which is the complaint, oh no, an equal sign, double. After that, a little bit of rule metadata, we have the create function. This create function is the thing we really care about now, the meat of the operation here. ESLint passes this a context, which we can see later is used to report an error. The rule uses this little query syntax. Every time we see a binary expression with a double equal operator, which if you're familiar with CSS queries, looks pretty much like a CSS selector. That's a member of an object that's returned that takes in the node. So this node is a binary expression with a double equal sign operator. Because we're trying to ban that, we now make a complaint, context.report. The data to that complaint is twofold. First, it is the message ID, which is the one message ID equal, and then it's information on which node we're complaining about, which is that binary expression from before. Cool, that's an ESLint rule. If you were following along at home and you just typed this out, congratulations, you've written your first rule. Good for you. We can make this rule structure a little more complicated if we go to, let's say, a different rule that has a fixer on it. In this one, we've added the fixable metadata that's required. And instead of going from double to triple equal, let's say that we're trying to use a tool that enforces proper usage of they, them instead of he or she to be gender neutral. So let's say that the rule should find all string literals that have the words he or she in them and suggest that they be replaced with they. It's a pretty similar rule. We have the create, which takes in a context. Instead of selecting on, as we see in the last slide, a fancy CSS-like selector, which needs to be represented with quotes because of special characters. For this one, it's just any literal. Once we get this literal, we check, is this a string literal? Is the value a string? And does the value include the phrase he or she? If it does, then we run this fix function, where the fix, it takes in a fixer, which is an injected thing from ESLint, and it calls the replace text method on the fixer. It replaces the text in the node with the node's value that has he or she replaced with they, wrapped in apostrophes. And then after that, we have the message ID in node, same as before. So I'm going to pause here and let's just bask in the glory of this as I get a drink of water. All right, moving on. We have discovered the core building blocks of ESLint, and now we're ready to get TypeScript in the mix. As I like to say, this is really ESLint cooking with gas. To give you a nice quick slide to screen cap and to summarize the differences, ESLint just scans the raw syntax of your code. It only understands what's immediately in front of it, a single file, the nodes, the raw text syntax of those nodes in that file. TypeScript builds on that. TypeScript understands what that code means. TypeScript takes a look at your project as a whole and builds an understanding of the possible types and behaviors of all the values and objects in your code. Taking an example, we have 3 lines of syntax here, a variable declaration and 2 console logs. Let's play a game. Is this safe? Meaning, does this code do what we think it probably should do? If TypeScript were reading this code, if we had a TypeScript project, it would know that the first variable is a string because it's assigned the value Josh. TypeScript can then infer, because this string first is a string, it has a .length method. So TypeScript understands that this line is okay. This is safe. First is first.length characters long. That's fine. All strings have a .length. TypeScript would know that, however, that the third line first.len is not likely safe because strings don't have a .len. So it would give us an error. Hey, you have a string and it doesn't have a .len. What gives? This is the crux of TypeScript. It reads in your code, understands the possible values, interprets what could happen, and lets you know if you mess something up. It also has a lot of really nice development time utilities, but we're not going to look at those so much today. We're just talking about the integrations. Cool. TypeScript. So let's look at another example. This is one where TypeScript really shines. Is this safe? Is this create API and then API.getHeroes pair of calls? Is this working, do you think? Look, just looking at it. Well, at first glance, it looks like it might be a bug because the getFruits API, getHeroes API, looks like it probably might return a promise. That's kind of standard for things with this naming. That might make sense. Or maybe it triggers the start of some kind of asynchronous fire and forget call, so you shouldn't await it. Maybe this code actually is safe to run after all. We don't know. From ESLint's pure typing, or that is non-typing perspective, there's no way to know just from this if this was a file with 4 lines of code. There's no way to know if this is safe. But from TypeScript's perspective, we can know more. Because TypeScript can see from the import, it can read all of the files and understand what's in there and see that, okay, getHeroes is a function that takes in, say, a publisher string and returns a promise. And it knows that because API is an object with a getHeroes that is that function. And then that promise returns an array of whatever this hero shape is. And this is because TypeScript has what's called a type system. It has a full understanding of the code. It's incredibly powerful. We're really just scratching the surface today, but just scratching the surface is already enough to really get some cool stuff from the rules. So we're going to level up now. We're going to do some cool things. These types are available for ESLint rules, this full understanding of your object types, using a plugin called TypeScript ESLint. It's this great new open source thing. Highly recommend. You can install it with a little bit more work than before. You have to install TypeScript, the parser, and the plugin. The parser is what allows you to read the TypeScript syntax. The plugin adds in rules that work with it. In your ESLint configuration, it's a little bit different now because TypeScript as a language behaves a little differently, and yeah, long story. The docs, again, are referenced in the slides. You can read the full documentation on what this format does. But what I'm really excited to talk about now is some of the rules that are available now with TypeScript. To start, my personal favorite lint rule of all time, we don't float down here. There are no floating promises. This rule is so useful. I've caught so many of my own bugs with this rule. The gist is that it catches unhandled promises. An unhandled promise is a promise that's created but then not handled in some way, meaning it's not .then or not awaited. It's just created. These floating promises, sometimes they're fine, but often they're symptoms of code accidentally forgetting to await and then for causing a bug. Or they're an intentional architectural choice of making a whole bunch of fire and forgets, but then the error cases or the race conditions aren't handled appropriately. So earlier on with the get heroes calls, no floating promises would have caught that because it would have said, hey, this is a promise that's created. You probably meant to await this. I have a lot of respect and appreciation for this rule. I did help write it. No for in array is another good canonical example of a rule that's only possible with the TypeScript type system or equivalent. Fun fact, it's not really a good idea to use an in loop for in over an array in JavaScript. It's not the end of the world most of the time, but it's a little slower because it it checks all, I always forget this, all enumerated values and enumerable, just some fancy JavaScript hoo-ha that's mentioned in the Stack Overflow that's in the slide notes. It's also a little extra if you need to do values of the key rather than just directly looping of, so over the values. So this rule is pretty great because it needs to understand what type a variable is, in this case values. It's not possible truly in pure ESLint because if you have, let's say, a function that takes in an input, ESLint wouldn't know what type that input is. It needs a TypeScript style type system to really reason through the code and understand what that input type would be. Lastly, for these rules, this one's a little more controversial, I think. No confusing void expression, which stops supposedly erroneous usage of return values from functions that don't return anything, also known as functions that return void. Console log is a good example of this. Console log returns nothing. There's no need to use the results of it for anything. It's undefined. So if you ever see an if console.log, might be a bug. Who knows? In this code, there's a potential bug here because someone's checking if not return status code, but return status code is missing a return at the end. So it's always going to return falsely undefined. So that's a potential bug that, again, only could be caught with TypeScript because we need to know what is this function type? What could it possibly return? Anyway, I said earlier we dabble our toes with automated migrations. Let's dive into these heroes. Suppose we wanted to change from a V1 to a V2 in our app for this Get Heroes API. Now, in theory, we could use TypeScript to completely change all at once. We change the type signature of create API, and it'll tell us when all places that are incorrectly using it are incorrectly still using it that way. But maybe it's a deprecated API, a soft deprecation, and in another version, we'll get rid of the other thing. So we can't really get rid of it. So we need a way to allow these things, but we still kind of want them, which is a surprisingly common situation when you have APIs and code. So we probably want something closer to an ESLint rule that'll tell us you are passing, let's say, a string now, but you should be passing an object. We can use a fixer, maybe even, to change the string to an object automatically. It should be, famous last words, relatively simple because this string is just being directly prepended with publisher colon and that whole thing wrapped with curly brackets. This is what the ESLint rule might look like in the original size, the original ESLint plan. It's a little more complicated than I prefer, but it's not so bad if you look through it. It's saying that it's fixable, and the input message would be that you should use the object input instead of the string. The create context method has a single query that's returned in the object. It's saying all call expressions where the callee name is get heroes. So all call expressions calling a function called get heroes. If they have a first argument of type literal, then we report an error. So if the first argument is, say, a string literal rather than an object, we report. That report comes with a fixer that replaces the text with publisher : and then the original value. So that's great. That actually does what we want for most cases. If we, again, look back at the previous slide, that would work for DC and Marvel. But what if someone passes a variable? This is not going to work for all cases. If you pass a variable, that's not a string literal. ESLint doesn't know what that variable is. It could be a literal, it could be an object, it could be an array, it could be anything. So we need a TypeScript type system or equivalent to catch it, to understand what's actually possible in that variable. So plan B is going to come in two parts because it is, again, a little more code. First, we're going to, as a TypeScript ESLint enable rule, try to hook onto the TypeScript APIs that are now available to us. This comes with a couple of things that are useful. The parser services are the TypeScript ESLint services that we're going to use to hook into TypeScript. From there, we want to use .program, which is the entry point to the TypeScript APIs. And we're going to want to use the type checker, which is the subsection of APIs specifically for asking what type things are in the type system, say variables. So we have the type checker, which tells us what types things are within the program, which is the collection of APIs available to us. Again, this is a little bit of an oversimplification of all the possibilities, so check out the slide notes if you want to see more. All right, the worst slide in the presentation, but also the coolest. This checks three things, or it does three things. First, we grab the corresponding TypeScript node for the ESTree node. TypeScript does have its own internal representation of this stuff. There's a map that you can .get. We then ask the type system, what is the type at that node? Or as they say in Code API, what is the type at that location? That type is a TypeScript form. It's an input type, which we're going to then check. Does that type system type look like a string? One oversimplified way of doing so is checking whether its flags bitwise operation matches the string-like bitwise. So the three things in order are, we grab the corresponding TypeScript understanding of the node. We ask TypeScript, hey, what type is it? And then we check, does that type match up to a string? So then only if that type matches up to a string do we report. And voila, we're done. That is a powerful TypeScript ESLint rule. I'm very proud of the things we can do in this new system, and I'm really excited that such a thing is available in just a couple dozen lines of code. Very good stuff. Recapping what we've talked about today. First, we started off the talk by going over the basic premises of ESLint. It's a tool that can find and fix issues in your code for you. We took a little bit of a detour to talk about Prettier. How is it different from ESLint? Please don't use ESLint for formatting rules. Use Prettier with ESLint. We then got back on track by looking at some good ESLint rules, which come with it, the built-ins. We looked at how we can use code mods within ESLint, little fixers from our rules to improve code quality automatically, respond to rule complaints. Later on, we got a little more hands-on with the underpinnings, the ASTs or abstract syntax trees. And last, we used TypeScript to make things awesome. Kabow. So thank you for listening to me. I really appreciate it. Additional thanks, of course, oh my God, to the conference organizers who are holding a conference in what a stressful time and ridiculous time to be doing such a thing. So thank you so much, NgPoland folks. Really appreciate you. Everyone, you can reach me at Joshua K. Goldberg on Twitter, and joshuakgoldberg.com is my website that has contact info and these slides. So thank you and enjoy the rest of the conference. Cheers.